Okay, welcome back to one more presentation on embedded platforms for prototyping. So previously we have seen the Arduino Uno, then your Intel Galileo and Intel Edison, right? So almost all are having the same principle of working. Only thing is that they are different by virtue of the on-chip features that they have, maybe in terms of the memory and other things, and some of the advanced features also some of these processors or computers were having, right? In continuation with that, today we shall discuss about one more of this category, right, which is as you can see, Raspberry Pi. So nowadays a lot of being spoken about Raspberry Pi prototype development platform or the environment, right? So on the similar basis we shall see how exactly your Raspberry Pi is different or how it is beneficial compared to the other type of things that we have discussed so far, right? Now there are different versions as you can see, but as of now what you can see here is the latest, but we have got the version 4 which has already come, right? So since 2016 February this version 3 was going on, and the version 4 also has come, right? Raspberry Pi 2 model B plus runs on a quad core ARM Cortex and runs Windows 10 IoT core and additional distribution of Linux operating system, and even the latest version Raspberry Pi 4 has come. Let me give you some of the striking features of Raspberry Pi in my subsequent slides, and as you can see this is how it looks like, and probably you have already seen a lot of such things earlier also, right? So if you look at the characteristic features just now, whatever I have mentioned, it runs on the OSs Windows 10 IoT Core, RISC OS, FreeBSD, NetBSD, Plan 9, Inferon AROS, and additional distributions of Linux such as Raspberry, Ubuntu on the board, right? So now you by this what you try to understand is on variety of operating systems it is possible for you to make use of the running of the Raspberry Pi. So this is one major advantage, right? And when I speak about this, the Raspberry Ubuntu, this is one of the very popular OS, right? So open source or modern day open source OS basically on Linux, specifically meant for your enterprise server, desktops and clouds. Basically it is meant for your cloud computing paradigms we have already seen, right? So and it supports the fastest and biggest digital operations. So nowadays a lot of being spoken about whenever you make use of Raspberry Pi, right? So the Raspberry and Ubuntu is the common kind of the operating system that you can select. If you go to the website of Ubuntu or if you go to the website of Raspberry Pi, so probably you should be able to understand in what way you can have the correlation between these, okay? And you have some other things also, right? FreeBSD. So this BSD it is basically, it stands for Berkeley Software Distribution. It is not being used nowadays, and we all are very much familiar with this Windows 10, right? So many operating systems support the Raspberry Pi. That is the reason why probably it has become very popular, and this includes the hardware and software, provides high performance computing and even graphics. So whenever you have the graphics that is being brought into picture, probably Raspberry Pi is one of the most appropriate solutions for you to use as long as your IoT applications involve the graphics, right? So this is one thing. And when we discussed about the Arduino Uno, we have seen that that was one of the limitations, right? When you have got too much of graphics or the calculation intensive codes are there, then that is not very much suitable for that by virtue of the limited ability of that, right? So but you know, when you compare the cost of Uno and Raspberry Pi, you would definitely understand the difference between the two, right? So as long as the Raspberry Pi is concerned, it cost varies somewhere from 2000 rupees to even 10,000 rupees depending upon the different versions that you have, right? And accordingly, when you pay more, definitely you expect more service or more provisions from that particular service provider, right? So that's why the high performance computing and even the graphics that is supported to a very comfortable manner in your Raspberry Pi, right? And again, if you look at the next point, the clock speed is about 40 times that of Arduino, and the RAM capacity is also much higher than that of Arduino. We have already seen what your Arduino has, and let us look into some of the specificational details of your Raspberry Pi, as long as its memory capacity and its speed and other specificational features are concerned, right? So that is the reason why your Raspberry Pi is so popular, and this is one which we very frequently come across whenever we speak about the Raspberry Pi. Okay, so then let us go into some more details here. Uses the processor ARM Cortex quad core. So we have seen about the single core earlier, then we have seen about the dual core, then now we are speaking about the quad core ARM processor. So when we discussed about your Arduino, then we have discussed about your Galileo, then we have discussed about the Edison, right? So how the different processors are different. So your Edison makes use of 086, whereas your Intel Galileo, right, makes use of X100 quad processor, right? That's what we have seen there. Now this is basically making use of a quad core processor. As you know, a quad core processor is much efficient in its operation compared to single core or dual core, right? Plus a graphic processor. So this is basically from Broadcom, right? So it's a brand actually. Broadcom is a brand, right? So uses a processor and a graphic processor, right, for graphics and video. That is the reason why the extensive video and audio, or the graphics, whatever I have made a mention earlier, they are very well supported by your Raspberry Pi, right? And the power required is about 4 watt, and it may be considered as a credit card sized computer, which you can carry anywhere you want, right? So if you have that, you can run almost all the kind of IoT applications with you, provided you are connected to the cloud or the other services that are necessary for you to run a typical IoT application. So these are some of the aspects related to the processor, as long as your RPI board is concerned, Raspberry Pi board is concerned. Now these are the specifications. Anyway, I am not going into the detailed discussion on these specifications. This is the version 4, whichever I have made a mention earlier, the latest version, right? You can just look at these things instead of going into the detailed discussion on this. This is a 64-bit system on chip, 1.8 gigahertz, 4 GB RAM, right? So you can just see here, and it has got the wireless LAN, of course, with the IEEE specifications, Bluetooth 5, low energy, gigabit internet. Then you can see here 2 USB 3 and 1 USB 2 ports, right, and horizontal 40 pin general purpose IO header, 2 micro HDMI ports up to 60 kp, right, which supports up to 60 kp. Then you have these things are not required because these come under the graphics specification, right. Micro SD card slot for operating system and data storage, right. So you can have both operating system as well as data storage, right. A compact keyboard, right, 5-volt DC via USB connector, operating temperature of 0 degree to 50 degree, right. So this is what is the dimension, which we are not really bothered about, right. It is a credit card sized computer, right. So now basically this gives you an idea about how exactly you have these specifications of your latest version of the Raspberry Pi, right, 4 version 4, right. So, and probably with these specifications you should be able to compare the features of your Raspberry Pi with its predecessors. So predecessors in the sense whatever we have discussed so far, could it be Arduino, the basic version, maybe Galileo or Edison, and later we will even speak about the beagle bone of your Texas Instruments. So that gives you an idea about how to go ahead with the specific selection of a specific embedded platform for prototyping. Okay, so these are some of the specifications. Please look at these things, right? The frequency at which it works, the capacity of your RAM, and even the on-chip features like your USB ports, Ethernet, the operating temperature, right? Even maybe the dimensions and all. And the most important is the graphical support, right? Support for the graphics, audio, video and all, right? So which we generally did not find in any kind of our previously discussed prototype platforms. Okay. So now let us move ahead with some more aspects of this Raspberry Pi applications, home automation and drones for the devices which need operating system that is different from the traditional PCs. So this I have already spoken about, right? So now this particular option is mainly for your cloud application, right? So they are more suited for your cloud application, I have already told you. So therefore your conventional operating systems, right, so they may be suitable for specific conventional cases, whereas if you want to develop an IoT application, you may require a customized or a tailor-made operating system which takes care of only that kind of activities. So that is where you may find your Raspberry Pi more relevant, because it is capable of running with a variety of operating systems, and even like what we have seen here as Ubuntu core, right? So it is also known as Snappy. In fact, Ubuntu, it is as you can see, it looks like an African name, and it is so, right? It is named after one of the African philosopher or something like that, right? You can Google it, right? So this Ubuntu core is basically an operating system which it's open source, right, for enterprise server. This I have already told you, the desktop applications and even cloud applications and IoT applications, right. Then we will look at some other aspects, right. Home automation, this I have already told you. Okay, the same thing is repeated here. Media server to IoT devices, broad functions as personal computer. This I think even I have made a mention earlier. If you have your Raspberry Pi computer, which is a credit card size computer, you can run any kind of application you want, because as long as you have the accessibility to the internet, what not you cannot do, right? So you will be able to do anything you want. So therefore it is basically it can be configured as your personal computer, right? In a networked security camera system, innovation, right? ATM applications and services, industrial IoTs. There are certain applications as long as the industrial IoT is concerned. Maybe there is one something called as Echelon. I just write it here. This one, Echelon, right? So you can just Google it out, right? So this is one software, right? So ready to run software, in fact, right? Based on the Raspberry Pi, especially for the IIoT, industrial IoT, and we have very categorically seen earlier, right? So how your industrial IoT is different from your conventional IoTs, right? So this is one thing. If somebody is really interested, you can go through these things and how the Raspberry Pi environment Echelon is used for your applications in IIoT. So this is one thing. Then certain features, because I have already told you the specifications and all, so getting the features is again a repeated one here. Anyway, we will quickly go through these things. Computers like prototyping, ease for developing media server and home or ATM surveillance system, IoT applications and services, coding in Python, C++, and the libraries. This is a very important thing. Again, I repeat, if you have the idea about the Python programming and if you have a Raspberry Pi with you, so it is possible for you, because the IDE, integrated development environment, whatever we have spoken, right? So this is very much supportive for you to run your own applications, right? So coding in Python, C++, and the other libraries, it is permissible as long as the Raspberry Pi is concerned. You can have your own applications run, right? Software runs on multiple environments: Python, Scratch, Squeak, ideally this I have made a mention earlier, C, Linux, right? BSD OS. So BSD OS nowadays they are not that used, right? Berkeley software distribution it is called, right? Windows 10 and several other OSs with external keyboard and display monitor. That means when I connect my Raspberry Pi, right? When I have my Raspberry Pi, it is very much similar or analogous that I connect one hard disk, external hard disk, right? Maybe 1 TB or something like that. So it gives me that kind of resemblance. So by connecting it to your computer, and you can open the Raspberry Pi environment on your computer, and you can run as if you are running your own applications, right? So you can connect it to cloud, right? And from where you can have the variety of applications as we have already seen earlier, right? Flexibility and ease of connecting to the hardware and to the external system. Most of the times using our embedded platforms, this is one hindrance or the difficulty that every developer would face, right? So when you want to interface your hardware with the systems, a lot of problems we come across. In fact, earlier we used to face a lot of problems. Nowadays these things have been made more and more user friendly, and this is one best example, your Raspberry Pi, wherein you have the flexibility and ease of connecting the hardware to the external system, right? So you don't have to do too many connections, right? So you have got your jumpers, headers, shields and all, which we have already spoken about, and as long as there is a compatibility between your external devices and these jumpers or shields, right, you can easily get them connected to the system, right? So any connectivity to the RPI, that is your Raspberry Pi, takes place through two USB host hubs and Ethernet connector. I have already spoken about that, right? So the two USB host hubs, right, and Ethernet connector in one of our previous discussions. This is about some of the features, and let me continue with those features now. In this, connectivity to the external memory through a micro SD slot, extended interface capabilities using serial peripheral interface, UART, I2C, 40 pin general purpose IO pins, supports Wi-Fi module, and of course all these features we have seen even in the case of your Arduino, maybe not to this extent, even in your Intel Galileo and Edison, right? So like that you have the extended interfacing capabilities using all these add-ons, that is SPI, UART, I2C, general purpose IO pins, and even having support to the Wi-Fi modules, right? So the RPI best usages are the media application for IoT, such as photos, right? Stereo audio, video, right? You have got the Raspberry Pi camera module also. So later, if time permits, some of these things I wish to tell you separately as a different thing from the curriculum, right? So how would you use your Python programming and Raspberry Pi to run your application? Maybe a 4 to 5 hours discussion on that. If time permits, definitely we will do that. And streaming of high definition HDMI output. So these are some of the important features of your Raspberry Pi embedded prototyping platform. Then after having seen this, right, so the Raspberry Pi, you can go to the website of Raspberry Pi and you can easily get into know, right, what are the additional things that you can have, because we have already discussed about the Arduino as well as your Intel Galileo and your Intel Edison. The same things are getting repeated except certain features that you can have in the different things which make them different from each other, so that you should be in a position to have an idea about which one you need to select. Okay, so now after having seen this Raspberry Pi, let us move on to the next one, in fact the last one in this particular category, the embedded prototyping platforms. Now this is called as the BeagleBone, right? We have started with Arduino and two such platforms based on Intel we have seen. Raspberry Pi is a different entity as it is, we can see. Now you have it the BeagleBone, which is from your Texas Instrument, right? Single board computing and communication, runs on RISC OS as well as Linux, right? Runs SoC, system on chip, which uses the processor and DSP processor for graphics and video. Again, this we have already seen, FreeBSD, OBSD, additional distribution of Linux such as Ubuntu boards, right? So all these things are as applicable to your Raspberry Pi. The system uses the processor ARM Cortex A15 core. So please try to differentiate between all these platforms by virtue of which processor they basically incorporate, right? We started right from your Arduino, Intel Galileo, Intel Edison, Raspberry Pi, and now BeagleBone. That gives the various operating abilities and features for each of these platforms, right? And you have the Texas Instruments DSP processor TM-S320C64X plus multimedia 4GB eMMC for graphics and video, and very much like to the Raspberry Pi, even your BeagleBone supports a vast the graphics, right? So because it makes use of the DSP processor for the graphics. The power required is just 2 watts. Memory on board is 2 GB and in-memory support plus micro SD cards, right? Up to I think 32 GB you can have the SD card memory extension. So in these senses, probably your BeagleBone is at par with the Raspberry Pi as long as the different operating specifications are concerned, right? So when we go to the next one here, yeah, you can just have a look at this BeagleBone board, again very much similar to what other boards we have seen earlier, right? So for media, 2D and 3D graphics, and even for video servers we will use this. Performance nearly seems to be about twice as fast as the Raspberry Pi, right? So this is one important feature as long as the BeagleBone is concerned. The Raspberry, this is a very important point to be noted. Now even we have the Raspberry Pi version 4, maybe as the technology grows, right? So you have got a stiff competition among the different versions. I need not tell you anything about that. When one version comes, right, to overtake that, the other version comes, again one more version comes, like that it keeps going. Ultimately for the users to decide which particular module you want to have for your particular applications, right? So those things you have already seen in your mobile phones, right? So many brands, so many variants, so it's very difficult for you to understand which brand you need to take, right? And every time you take a brand, the very next moment you will feel that I should have taken that, I should have taken this and all, right? So that part we will not discuss here. So performance nearly seems to be as twice faster than Raspberry Pi 2, but now since we have got the Raspberry Pi 4, maybe we need to have a separate comparison for all those things. Okay, then let us look into some of the features, which some of the things may be repetitive here. A single board computer and communication board, earlier also we have seen. Prototyping is for media, graphics, video servers needing IoT applications. IDEs for BB includes environment for code development in Python, Scratch, Squeak, right? Cloud9, Linux, C Linux and BSD OS. This also we have seen. Programmability of number of times downloading the code through port during edit, test, debug cycle and development. This even we have seen for your Intel Galileo and maybe your Arduino, right? Pulse width module, CAN, the control area network, serial peripheral interface, DVI, integrated real-time clock and reset button to reset the sketch and one second, any attached modules, right? So these are some of the important features. Now when you look at the features of all these things whichever we have discussed, they almost look alike, right? So please draw a clear line between these by having a table of your own, so that which are the points that differentiate the performance of each of these embedded platforms that we have discussed. Okay, then flexibility and ease of connecting the extended memory and hardware connectivity board to external sockets, right? Then stereo audio, Ethernet to micro SD slot, extending interfacing capabilities using 157 general purpose IO pins. So far this number whatever we had seen was limited to 40 in our Raspberry Pi, right? So you can have the extended operation up to 157 general purpose IO pins. Flexibility and ease of connecting the hardware connectivity board to the external through 3.0 and USB hub with 2 USB 3.0 ports, stereo, audio, video and stream of high definition HDMI output. So these are some of the other features, right? So which you need to understand as long as the BeagleBone prototyping platform is done, right? Now this gives us an overall picture of how the different types of the embedded platforms can be used or can be chosen as long as a typical IoT application is concerned, right? Like that you have so many other things also, like you have got something called as I just write here yeah, that is embed from your ARM, right? One second. right? Embed ARM board, right? ARM embed, right? So it is also an open source, similar to what we have there, right? So like that, you have something else called as one second, yeah. I'm not getting that right now. Anyway, you have got so many other type of embedded, prototyping platforms. But please get to know that here, whenever I'm using this board, whether it is a BeagleBone or whether it is Intel Galileo or your Raspberry Pi or your Arduino, right? The very purpose of this is to have the connectivity between entities. One is your physical layer here, I just call it as physical layer, then your network, or through that you have the application layer, right? So whatever you want to have the communication from this side or from this side, it must be enrouted through your embedded platform for prototyping, EPP, right? So to run a particular application using your IoT, maybe a street light control or a smart umbrella, whatever the examples we have taken, your automatic ice cream vending machines, right, which is connected to the cloud, right? Or you may be having inventory control, tracking of some systems using your different communication technologies, right? Your ATM machines, right? So whatever the way in which you want to establish the connection between a physical entity through your smart sensors or the basic sensors and to your cloud, so these things are very essential. Without these things, it is not possible for you to have the connections or have the connectivity or the operation. So with these things, now we have come to the almost end of this particular discussion, right? So wherein in this particular topic, what basically we have discussed is the embedded prototyping for embedded devices in IoT and machine to machine, right? What do we mean by prototyping that we have seen? What do we mean by embedded system? What do we mean by embedded device? What do we mean by microcontroller? Anyway, all of you know about this: timers, ports, USB ports, the general purpose IO pins, right? Boards, platforms, modules, shields, right? Headers, jumpers, interrupts. Then we have come across one important aspect, of course, which we had even made a mention earlier: integrated development environment. Then we have looked into the embedded computing basics with the embedded software, discussion on the embedded software, bootloader, then the operating systems, real-time operating system. Then we have discussed in detail about the integrated development environment, wherein we have discussed about the simulators, right? So after that, we have discussed about some of the aspects related to system on chip, okay? Then the different embedded platforms for prototyping. We have started from the Arduino. We have started the discussion on the architectural features of Arduino, right? So Arduino Uno, Arduino Fio. Then we went on to the Intel Galileo, the Intel Edison, right? So then today in this particular discussion, we have discussed about the Raspberry Pi and the BeagleBone from your Texas Instruments. We have come across the then the Intel based, the Raspberry Pi, and even the Texas Instrument based type of the prototyping platform, right? So in our next presentation, we will look into some of the aspects how you will have these things connected to the cloud. So now basically what we have seen here is this particular part. So we have discussed about the on-chip features that is SOC, whatever you have here. Then later we will try to see how exactly we will be able to establish the connection from this to your internet connectivity or your cloud. So which type of protocols that we need to follow, right? So then how do you connect your Arduino to Wi-Fi, or even from Wi-Fi how exactly you establish the connection to your cloud and other things we shall discuss in our next presentation, right? So I will stop here now. If you have any doubt here, and I request all of you to make one important task here. You have a comparison table, something like this, right? So wherein here you have the features, here you have the features, and followed by all these things, right? So that is your Arduino, then the next one maybe your Intel Galileo, then Intel Edison, right? Then your Raspberry Pi here. Then like that, the next one you can have the BeagleBone, right? So after having these things, so how exactly you will be able to differentiate between each of these, right, with respect to a particular feature that you have selected, that you make. So then only you will be able to understand the basic difference between all these things, right? So with these things we will stop now. If you have any doubt or difficulty, you get back to